It's been an exciting week in quantum computing. IBM announced a roadmap to deliver the world's first large-scale fault-tolerant quantum computer by 2029. That's a big breakthrough. But what did it take for IBM to be comfortable in committing to this roadmap? Today we're going to talk about one hardware engineering challenge to deliver this new kind of computer. Now, to achieve fault tolerance, you need error correction. I've talked in a previous video about a breakthrough IBM made last year in an error correcting code called the gross code, which is 10 times more efficient than the former state-of-the-art error correction code. The challenge with the gross code, though, is that it needs more connectivity between the physical qubits. In fact, they laid that out in the shape of a torus, which is kind of like the shape of a bagel. Here's the problem. You can't make a quantum chip in the shape of a bagel. In fact, you can't get the connectivity that's required for this gross code simply by laying the qubits out on a 2D plane, which is what we've done to date. Unless you, as my IBM research colleagues put it, break the plane. If you imagine this is your quantum wafer and all your qubits are these little dots laid out in the 2D plane, you will need to connect some of these qubits to further away qubits instead of just to their nearest neighbors. These couplers are what will give you the connectivity that's required to achieve the connectivity requirements in the gross code. What makes this such an engineering challenge is not just creating these couplers, but also ensuring that the qubit-to-qubit error rate stays low while also minimizing crosstalk amongst these couplers. It's not an easy task, but the roadmap is there. In fact, IBM will deliver this year a quantum chip called the Loon chip, which will give a demonstration of these C couplers, as they call them. Again, this is just one piece of the puzzle in delivering a fault-tolerant quantum computer. But what use cases could you see for such a computer? Let me know in the comments below.